Hello students, welcome to EDAMIGO, an initiative by GATE and ECE top 3 rankers. So I welcome you to part 2 of the lecture series of previous year GATE questions of Signals and Systems of Electronics branch. Here we are solving the questions and also providing you the concepts behind the questions. So this is the part 2 of the lecture series. We have already completed part 1. So you can go through that lecture if you have not gone through that. So let's begin with the question. So this is a simple question. Here it is given that xn is input and yn is the output, and this is the relationship between input and output. We have to find that is the system causal, stable or not. So solution. First of all, what is a causal system? A simple definition to the causal system is when present output value does not depend on future values of input, then system is a causal system. Okay, that it must not depend on the future input. Okay, that is the present output can depend on past input and slash or present input. The only thing is it cannot depend on the future values of input. Okay, so it can depend on past input and present input, not on the future input values. Okay, so it is given that yn, that is the output, has a relationship with the input, that is n mod of xn, where n is varying from 0 to 10, and xn minus xn minus 1 otherwise. Okay, so it's a very simple to see that from 0 to 10 value of n, yn is equal to n times mod of xn, that is the present value of output is depending on the present value of input only. Okay, the present output is depending on the present input only, because you can see that y0 is equal to 0 times x0 mod, y1 is 1 times mod of x1, that is y1 is dependent on x1 only, y0 is dependent on x0 only, y2 is dependent on x2 only, and similarly y10 is dependent on xn only. So present output is dependent on the present input only. For other values, we can say that yn is equal to xn minus xn minus 1. So the present output is dependent on the present input minus the previous input. So here we can see that since the output is not dependent on the future input, so the system is causal. So it's a causal system. Okay. Now we have to check the stability of the system. Okay. So let me tell you the method to check the stability of the system. Stability of a system. Okay. So generally we check the BIBO stability of a system. What is BIBO means? It is means bounded input, bounded output stability. So what is the meaning of this? When we give bounded input to a system, so what is the meaning of bounded input? Bounded input means that value of input at any time instant should not reach infinity, or we can say that at all time instant value of signal is finite. So I will have to add a page here because I'm giving you a lot of explanations here. So that's why. So at all time instant the value of signal is finite. So that is the meaning of bounded signal. So if the input is bounded, then output should also be bounded. Okay, so this is the requirement and we will check this. Now generally, okay, so I'm writing the method. So the method is when relationship between input and output is given, then to check DIBO stability, the best method is to give UT or UN as input to the system, because we know that UT and UN are always bounded, because for UT the value of signal is always 1, for UN also the value of signal is always 1 or 0. Okay, so give UT or UN as input to the system and check the output. If output is bounded, then system is stable, else it is not stable. Okay, okay, so I will add a page, one more page here. I think I added it. Now let us see the system. It is given that yn is equal to n times xn mod for n 0 to 10, and it is xn minus xn minus 1 otherwise. So when un is the input, then we can see that for un the output will be n times 1 for n 0 to 10, and xn minus 1, so it is 0 otherwise. Okay, because for example, if we are taking n as 11, so for n equals to 11, y11 will be equal to u11 minus u10, and both the values are 1 minus 1, that is 0. Similarly, n for n equals to 12 also, y12 will be 0, n equal to 13, y13 will be 0, so all these will be 0. So we can say that yn is equal to n for n equals to 0 to 10 and 0 otherwise. And we can see that this output is a bounded output. Okay, it is not going to infinity. So that's why we can say that this system is DIBO stable system, or we can say that, simply say that it's a stable system. So the system is causal and stable. We have proved that. So option A is a correct answer to the question. Okay. Now let's move to the another question. Here two signals are given, xn and hn are given to us, and it is given that both are non-zero only for n equals to 0, 1 and 2 and are 0 otherwise. Values of xn are given to us, h0 is also given to us, y1 is given, yn is the output, that is a convolution of the two signals, y1 is given, y2 is given, and we have to find this. Okay, so it's a simple convolution problem, and here I will give the another method for convolution of two discrete signals. This is a very good method. As we know the formula, yn is equals to xn convolution hn, and the formula is n equals to minus infinity to infinity xn hn minus m. Okay, so this is the formula, we all know that. Now let me tell you a method to solve the question. So we have xn, which is x0, that is at 0 location, x1, x2. Okay, hn is also like this, h0, h1, h2. Okay, now for convolution, for convolving these two, we will write them like this. X0 will be a number, x1 will be a number, x2 will be a number. Okay, I will write it like this, in this order. h0 will be a number, h1 will be a number, h2 will be a number. Now I will multiply these numbers, okay, as we used to multiply in maths. Okay, first of all we multiply h0, okay, this number with x0, then with x1, then with x2. Okay, like we do in maths. Okay, so we'll get x0 x0, h0 x1, h0 x2. Okay, now in maths also we used to put a cross here. Now we will multiply h1 like this. So we'll get h1 x0, h1 x1, h1 x2. Now in maths also we used to put two cross like this, and then we will multiply h2. So h2 x0, h2 x1, h2 x2, and now we will add them. Okay, now when we will add, in maths we used to put a carry forward, but here we will not put any carry forward. Okay, no carry forward. Okay, what will the number which we'll get, we will put it right here. So here we are getting h0 into x0 plus nothing plus nothing. Okay, so we'll get h0 into x0. Here we will get the sum of these two, that is h0 into x1 plus h1 x0. Here we will get the sum of these three. Here we will get the sum of these two, and here we will get only a h2 x2. Okay, now this is the convolution result, and this is the first term. Okay, this is the first term of the convolution result. So yn is equal to h0 x0, this is the first term of the convolution, comma, h0 x1 plus h1 x0, comma, this is the third term, fourth term, fifth term. Okay, similarly all these terms will be there. So this is the method of convolution of two signals, which is very fast method, and we will not use this formula because it will give us a very lengthy method. So this is the fast method to solve the convolution. Okay, now as we know that the value of x0, x1 and x2 is given to us, that is 1, 2, 1, and h0 is also given to us. Okay, so let me write the values. 1, 2, 1, this is x0, x1 and x2. h0 is also given to us, that is 1. Okay, and let us say this is h1 and this is h2. Now we will do the multiplication as I have already told you. 1 will be multiplied by 1, so we will get 1. 1 will multiply by 2, we will get 2. 1 will multiply by 1, we will get 1. Then we will put a cross sign. Then we will multiply h1 with 1, so h1. Then with 2, that is 2h1. Then with 1, that is h1. Then we will put 2 crosses. So h2 will get multiplied by 1, 2h2, and then h2. So we will get 1, 2 plus h1, 1 plus 2h1 plus h2, h1 plus 2h2, and h2. Okay, so I will have to add, okay, no need to add the page, already there. So we have yn is equal to 1, comma 2 plus h1, comma 2h1 plus h2 plus 1, comma h1 plus 2h2, and the last term is h2. And the last term is h2. Okay, so this is the first term, this is y0. Okay, so it is given that in the question itself, it is given that the information is y1 is equal to 3 and y2 is equal to 4. y1 is equal to 3. So we can say that 2 plus h1 is equal to 3. This implies h1 is equal to 1 and y2 is equal to 4. This is y2. That is 2h1 plus 1 plus h2 is equal to 4. Since h1 is equal to 1, so we can say that h2 is equal to 1. So h1 is also 1, h2 is equals to 1. Now we have to find 10 by 3 plus y4. 10 by 3 plus y4. So 10 by 3 plus y4 is the answer that we have to give. Now we can say that this is y1, y2, and this is y3. So y3 is 10 times h1 plus 2h2 and y4 is h2. Since all have the value is equal to 1, so it is 3 plus 1. So 31 is the correct answer to the question. So here I stop in this part. So we will be solving more questions in the next part of the lecture series. So thank you students. Keep sharing these lectures and give us the feedback. Thank you.